Spontaneous reactions are reactions which will happen on their own. That means there is no need of any external agency required there for the reaction to take place. What is already produced by the cell is 1.1 volt. I am applying another electricity or another external EMF which is opposite to that, which is same value, that is 1.1 volt. Now what is the overall redox reaction which is taking place here? Zinc plus Cu2 plus gives Zn2 plus plus Cu. Right. So this is the reaction which is taking place, overall redox reaction. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with a new chapter, that is chapter 2 of your syllabus, Electrochemistry. So in today's session, I understand what is electrochemistry, what we are going to study in this chapter. Then we'll move on to what is a redox reaction, what is electrochemical cell, what is Daniell cell, and how you can represent a cell. All of this we are going to discuss in today's session. So what we are going to study today is about the chapter electrochemistry. Okay, so from the name itself you can understand few things, electro and chemistry, right? So from this what you can understand, electro stands for electricity and chemistry stands for the chemical reactions. So basically in electrochemistry there is an interconversion, or we are going to study about the interconversion between electricity and chemical reactions. That means how from chemical reactions, or when chemical reactions occur, how it can be converted into electrical energy, and once electricity is passed or electrical energy is given, how can you bring about a chemical reaction. So it is basically an interconversion between electrical energy and chemical energy. So the electrochemistry is a study of production of electricity from energy released due to chemical reaction and the use of electrical energy to bring about the chemical reaction. So in either ways it can happen. That is, either it is the production of electricity by chemical reactions, or else by the use of electrical energy, we bring about chemical reactions. Okay. So the first one is chemical energy to electrical energy. That is conversion of chemical energy to electrical energy. That means chemical reactions will take place, and based on that, the current will start flowing and you will get an electrical energy rate there. So this type of reactions are spontaneous reactions. Now what are spontaneous reactions? In first PUC already you have studied. Spontaneous reactions are reactions which will happen on their own. That means there is no need of any external agency required there for the reaction to take place. That means the chemical reaction will take place on its own and the electrical energy or the electricity will be produced, right? So such reactions are spontaneous reactions. Now you have electrical energy converting into chemical energy. So these are non-spontaneous. That means they have to have a external agency for the reaction to proceed. That means you are providing an electrical energy, right? So that is the external source, so that chemical energy or chemical reactions will take place. So these are the two parts which we are going to study in this chapter in detail, right? So before moving on to the details of conversion of chemical energy to electrical energy or electrical energy to chemical energy, in electrochemistry all the reactions that we are going to study is based on redox reactions. So in first PUC already in a detail you have studied this in chapter redox reactions, right? So let's quickly revise what we have already studied in first PUC itself. So what is oxidation? Oxidation is removal of electron, right? It is removal of electron. So this is zinc metal, from which if you remove 2 electrons, it gets converted into Zn2 plus by the removal of 2 electron, right? So oxidation is the removal of electron. Then what will be reduction? Reduction is the addition of electron. So Cu2 plus, copper 2 plus ionic form, this 2 electron is being accepted by the Cu2 plus and forms the copper, right? That forms the copper metal. So this is an oxidation and reduction process. So these two processes happening together, right, that is oxidation and reduction happening together, will form the redox reaction, right? A reaction in which both oxidation and reduction takes place simultaneously is called a redox reaction, right? So zinc plus Cu2 plus gives Zn2 plus Cu. So here you can see what is happening, zinc getting converted into Zn2 plus, oxidation is happening, as well as Cu2 plus is getting converted into Cu, reduction is happening. So both reactions, that is oxidation and reduction, is happening in the same time, that is called as a redox reaction, right? So now we are going to study the different types of cell, that is electrochemical cell and electrolytic cell. So first we will be starting with electrochemical cell. Now what is this electrochemical cell means that it is a cell in which there is conversion of chemical energy to electrical energy. Right, chemical energy to electrical energy. Then in electrolytic cell, what will happen? Electrical energy is getting converted into chemical energy. So how you can remember this? Electrochemical cell. You have this word chemical here, right? So remember, it will convert chemical energy to electrical energy. And electrolytic cell converts electrical energy into chemical energy. So first we are going to study in detail about electrochemical cell, wherein we will be discussing a specific electrochemical cell, that is dianyl cell, which is very, very important, right? So moving on to electrochemical cell. So this whole setup is called as a cell. That means you have, this is one beaker in which you will have a electrolyte and a rod or a electrode will be dipped in it. And in the same way you have another beaker in which another electrolyte will be present, and in another beaker you will have an electrolyte in which another electrode will be dipped inside. So these two together is called as a cell. Okay, this is called as a cell, and that is why it is called as an electrochemical cell. This whole setup is called as a cell. Now only this part, that is the beaker containing the electrolyte and this electrode, this is called as one half cell. Right, so this is one half cell, this is another half cell, that is the electrolyte plus this electrode. This is called as one half cell, this is called as another half cell. Now these two electrodes, you can see one electrode here, another electrode here. These two are connected by a wire through which the electricity will be passed or the current will be flowing. That means in one of the half cell oxidation will take place, and in another half cell reduction will take place simultaneously. By this redox reaction, what will happen? Electrons will start flowing through the wire, and what will happen? Opposing the movement of electrons, current will start flowing. That means electron, if it is moving in that direction, current will be flowing in this direction. So what you are going to get, due to the reactions, oxidation and reduction taking place, and electricity is being produced. So this is the conversion of chemical energy to electrical energy. I hope it is clear. So this is an electrochemical cell. Okay, so here and you can see the example I have taken here is a zinc rod which is dipped in zinc sulfate solution. Okay, zinc rod dipped in zinc sulfate solution, and you have copper electrode dipped in copper sulfate solution, and these are two electrodes being connected through a wire. And you have another setup also here. You can see an inverted U-tube structure, right? A U-tube which is put inverted into these two electrodes. So you have an inverted U-tube which connects these two electrolytes, right? So this inverted U-tube is called as a salt bridge. Okay, now what is the use of this salt bridge? We are going to study in the next slide. So I hope this basic connection and what are the things which is present in an electrochemical cell is clear for you. So in here you have zinc dipped in zinc sulfate solution, and you can see a negative charge here. So this is the negatively charged electrode, and the negatively charged electrode is called as the anode, and the positively charged electrode is called as the cathode, right? And what you have to remember is in an electrochemical cell, in the anode always oxidation will take place. In anode oxidation will take place, and in the cathode reduction will be taking place simultaneously. So what happens together? A redox reaction will take place. Because of that, electricity will be produced. I hope it is clear. So in an electrochemical cell, anode oxidation will take place, cathode reduction will take place. Clear? So now moving on, already we have studied this setup, right? And electricity will be produced in this. Chemical reactions are taking place and electricity will be produced here. A current will be produced here. So that is the current of this particular cell. Okay, and that is called as the EMF. Now what happens? We are supplying an external electricity, right? Already because of the chemical reactions taking place, and electricity will be produced here. Now what we are going to do is we are applying an external EMF or external electricity we are going to provide. Now there are three conditions and what is going to happen, let's see. Now if I am applying an external electricity from outside which is less than 1.1 volt. 1.1 volt is the electricity which is produced by this particular cell, that is zinc dipped in zinc sulfate and copper dipped in copper sulfate. This is called as a Daniell cell, okay, or a galvanic cell. So the EMF which is produced by this particular setup or this cell is 1.1 volt. So if I am applying an external EMF or external electricity which is less than 1.1 volt, what is going to happen to the cell? Nothing is going to happen. The reaction is going to remain as it is. Oxidation will take place in the anode, reduction will take place in the cathode. That is, zinc will undergo oxidation, copper will undergo reduction, electricity will be or the current will be flowing in this direction itself. Electrons will go in this direction, current will be passing through this direction. There won't be any change if the external EMF we are producing is less than 1.1 volt. Now, if the external EMF we are producing is equal to 1.1 volt, now what will happen? What is already produced by the cell is 1.1 volt. I am applying another electricity or another external EMF which is opposite to that, which is same value, that is 1.1 volt. So altogether what will happen? The reaction will stop. Right, what will happen? There will be no current which will be produced because the external EMF I am producing is also 1.1 volt. I hope it is clear. Now, the last case is when the external EMF is more than 1.1 volt. So, we are applying an external EMF which is more than the EMF which is already produced by the cell. So, in that case, what is going to happen? The reaction is going to reverse. That means now your anode is going to act as cathode and cathode is going to act as anode. The reaction is going to reverse. So in that case, what is going to happen? Electrons will flow in this direction and the current will start flowing in this direction. So what you can see in these two cases, yes, initially when the external EMF is less than 1.1 volt, there was no change. Now if external EMF is more than 1.1 volt, what is happening? The reverse is going to take place, right? The electrons will flow in this direction and current will pass in that direction. So this part is very important when the E external is more than 1.1 volt, because this is the case when your electrochemical cell is going to behave as an electrolytic cell. Electrolytic cell. So this is an important question also. When does an electrochemical cell behave as an electrolytic cell? That is when the external EMF that we are applying is greater than 1.1 volt. In that case, what is exactly happening? We are applying an external energy, right? External electrical energy so that the chemical reaction is taking place. So what is happening here? It is going to behave as an electrolytic cell, right? So these three examples are very important, and when electrochemical cell is going to behave as an electrolytic cell. Now moving on to, as I told you, Daniell cell or galvanic cell. This is very important. Okay, so it is the same setup as we have studied in electrochemical cell. The same example it is, that is a Daniell cell, wherein which you have an anode and you have a cathode, right? So the negatively charged electrode is called as an anode and positive one is called as a cathode. And here you have in Daniell cell, it is going to be zinc electrode. In Daniell cell means this electrons and electrolytes will be a same one itself. You can't change it. Daniell cell, specifically the electrons and electrolytes are the constant. So you have zinc electron which is dipped in zinc sulfate solution, that is acting as the anode. So this zinc electrode will act as the anode, and you have copper rod or copper electrode dipped in copper sulfate solution which acts as the cathode. Okay, and then through a wire it is going to be connected, and you can detect the electricity and you can measure the electricity by connecting it to a voltmeter here, right? So what is going to happen? The reaction is going to take place here and electricity will be produced, and you can see a salt bridge also here. So what is the use of that we are going to study here. So in anode, what is going to happen? Anode, as I told you, oxidation is going to take place. So what is happening? Zinc is present there. Zinc is going to get oxidized to Zn2 plus by removing 2 electrons. Oxidation means removal of electrons, right? Now you have the cathode in which reduction is going to take place. So you have the Cu2 plus that is present in already the copper sulfate solution. You will have Cu2 plus, and the electrons which is produced from here, you have electrons which is produced by the oxidation of zinc, right? That will pass through this wire and it will reach here, and the copper 2 plus ions will accept these 2 electron and form Cu solid, that is your copper metal. I hope it is clear. So what is going to happen? This copper electrode, the size of it will increase because the copper is going to get deposited here. And what will happen to the size of your zinc electrode? It will get reduced because it is undergoing oxidation by the removal of electrons. So this is the reaction which is taking place as anode and cathode. Okay. Now what is the use of the salt bridge? Let us see. Salt bridge is an inverted tube which contains inert electrolyte like KCl or KNO3. So it is an inverted tube in which you will have KCl or KNO3, which is an inert electrolyte, right? And it maintains electrical neutrality between the two electrolytes. In absence of salt bridge, a reverse potential difference is set up in the half cells, which results in breaking the continuous supply of voltage. So this means that the salt bridge will help in maintaining the electrical neutrality between the two half cells. That means if the number of anions or cations is more in any of these electrolytes, which will maintain the neutrality or which will break the electrical neutrality of these two half cells from the KCl or the KNO3, what will happen? The ions will flow into these electrolytes so that the neutrality will maintain. Also, another important function of the salt bridge is to complete the circuit. That means from here to here you have an electrical wire which is used to complete the circuit. But these two electrolytes, how it is being connected? Only by this wire it is connected. The circuit should be always complete, right? So the salt bridge is also being used to complete the circuit. So these are two important functions of the salt bridge, to maintain the electrical neutrality as well as to complete the circuit. So these 2 points are very important to remember. So what is happening here? So now let's see which is the reactions which is actually happening here. So already I have mentioned which is the oxidation process and reduction process which is happening here. So now we are going to see how to exactly represent these reactions, right? So as discussed already, in the oxidation half cell, that is in the anode, what is the reaction taking place? Zn is getting converted into Zn2 plus and 2 electron is released. Okay. Now, this 2 electrons is being accepted by Cu2 plus to form Cu, wherein reduction is taking place. Now, what is the overall redox reaction which is taking place here? Zinc plus Cu2 plus gives Zn2 plus plus Cu. Right. So, this is the reaction which is taking place, overall redox reaction. So, what is happening in the left side altogether I have written here, and right side I have written here. So, you can see this 2 electron and 2 electron will get cancelled. So, that is how you get the overall reaction. So, here it is also important to mention the physical state in which it is present. Zinc, it is a zinc rod, so it is in solid state. Cu2 plus is in aqueous state, right? And Zn2 plus also in aqueous state. Copper is in the solid state. So this is the overall reaction. Now let's take an example. Write the half cell and net cell reaction in which the cell is represented as. So in here, this is called as a cell representation. Okay, so cell representation is given. You are supposed to write which is the oxidation reaction, reduction reaction and the overall reaction. So in here, whatever is written first, that will be undergoing the oxidation, and the second part will be the one which is undergoing reduction. Okay, so this oxidation part, from what to which state it is going to change, we are going to write it with this slash which is here, and this double slash that you can see, that stands for the another half cell. So this is wherein oxidation is happening, this is wherein reduction is happening. That will be separated by these two slashes. I hope it is clear. So in here, what we are supposed to write in oxidation half cell, what is going to happen? That is Ni is getting converted into Ni2 plus, right? So nickel is getting converted into nickel 2 plus by the removal of 2 electron. And reduction, what is happening in the reduction half cell? Reduction half cell, Pb2 plus is there, lead 2 plus accepts these 2 electron and forms what? Lead solid will be formed. So this is what is happening. So what will be your overall reaction then? Overall reaction together, that is nickel plus Pb2 plus gives, what happens to these 2 electrons will get cancelled, right? So you will have nickel 2 plus and lead in the solid. So this will be in the aqueous state, right? Nickel 2 plus, lead also in the aqueous state and nickel in the solid state. So this is the overall reaction. I hope it is clear. Now let's take this example also. So this is wherein oxidation is taking place, that is Cu getting converted into Cu2 plus, oxidation. Now Ag plus is converted into Ag, that is by reduction. Right. So let's write here also what is the oxidation process happening. Cu getting converted into Cu2 plus 2 electron. Right. This is in aqueous state and this is in solid state. Reduction, what is happening? Ag plus accepts these 2 electron and forms Ag. So in here there is something you have to do. 2 electrons are present here, right? So you have to multiply this by 2. 2 Ag will be formed. I hope it is clear. There are 2 electron which is accepted, right? So it was going to be 2 Ag. So now what is the reduction process happening here? Ag plus accepts these 2 electron and forms 2 Ag. So here also you have to multiply it by a 2 because we are using 2 accept, or the silver is accepting 2 electrons. Now what will be the overall reaction here? Cu2 plus Ag, and it will form Cu2 plus 2 Ag. So this will be the overall reaction. So I hope this is clear. So this is how we are representing a cell, and this is how we write the oxidation and reduction process and the overall reaction which is taking place. So in the next session, we are going to study what is electrode potential, standard hydrogen electrode which is called as She, and then electrochemical series, EMF of the cell, and what is Nernst equation. So I hope the concepts that I have covered in this session is clear for you. So that's all for today. Thank you.